first of all, thanks for attending. Today I'm going to talk a bit about the Elm programming language and how it solves some of the problems that we as UI developers face. So, a bit about me. My name is McKeaveney, and I'm a software engineer at Rapid7 here in Belfast. So, I'm going to talk a bit about the modern front-end stack, JavaScript today, libraries, frameworks, how it's all moving very quickly. Basically, what is Elm? What kind of language it is, what it gives us, a bit about mutable global state and the problems it presents us, a bit about imperative logic and how we can use Elm to kind of clean up really imperative code, runtime errors and unsafe APIs, and how Elm's type system helps us catch that, Elm and the DOM, how we render to the DOM, how we manipulate HTML with Elm, and the tooling and architecture that Elm provides out of the box. And if we've got time, I'll show a quick demo as well. So, JavaScript today, anyone who's done any kind of JavaScript at scale or in the enterprise knows how quickly it moves. There's an absolutely massive amount of tools, frameworks, libraries, Vue, React, Ember, Angular, the list goes on. And in terms of libraries, these come out on almost a weekly basis. So JavaScript is so ubiquitous on the client and the server, and we've also seen it move into the mobile app space with the likes of React Native, so it's absolutely everywhere. One of the terms that you might have heard people talk about is JavaScript fatigue. So with all this stuff happening so quickly, it actually becomes a bit of a nightmare because you settle on a stack that you like, and 2 weeks later it's obsolete, or versions came out that makes whatever you've written just no longer works anymore. So people get a bit tired of that. As well as that, there's different paradigms as well. Object-oriented, functional, and that presents its own challenges where you have arguments about people who like to do things in an object-oriented style versus people who like the functional or pure functional style. Applications are getting bigger, our bundles are getting bigger, and as a result, users are having to download more JavaScript. And we have code splitting, which is a lot easier nowadays than it used to be. However, people with slower internet connections and less bandwidth are starting to suffer as a result of these apps growing. And because we have so many of these nice frameworks and libraries, more logic is starting to move to the client. We can do a lot more in our JavaScript applications than we ever could before. So what I'm basically trying to say is there's so much going on, and it's almost hard to know where to start and which solutions to choose when you're building a front-end application. So enter Elm. Elm's a functional programming language that compiles to JavaScript, and basically it's built, it's a compiled language, and the compiler is written in Haskell. And you'll notice, as you see some of the examples in the common slides, a lot of Elm's syntax is quite similar to Haskell. So I'll just jump straight into it. Elm, these are the 4 pillars of Elm almost. These are actually from the docs, and are the kind of nice points that would attract the developer to use Elm. So no runtime errors in practice, no null and no undefined is not a function. We don't have null and undefined in Elm, and it deals with that using a union type, which you'll see an example of later. It has friendly error messages to help you find features or add features more quickly. So the compiler shows extremely helpful error messages, and again you see examples of that later, and it helps you catch a lot more compile time as opposed to runtime, which you may be used to with JavaScript. Well-architected code that stays well-architected as the app grows. Elm apps have a very clean divide between the view, the update, the model, all that kind of stuff, and as your app grows it's very easy to see where you need to split it and how you need to organize your app. And automatically enforced semantic versioning for all Elm packages. Elm's actually able to tell, using its powerful type system, when a release is going to be a breaking change, and it's able to say, oh, this needs to be a minor version, this needs to be a major version. And whenever you go to update one of the dependencies of an Elm package, it'll be able to tell you whether updating to that version will break your code before you've even pulled it in. So just to show some syntax, in Elm we create functions by just declaring the name and then followed by the arguments. And the arguments are declared with white space as opposed to parentheses and commas that you might be used to in Java or JavaScript. So we have a isCool function. It takes a name and appends isCool to the name. And we have a multiply function, takes an x and a y argument and multiplies them together. We can then call them by just passing the arguments straight after with white space, as I mentioned. So we call nidevconf, nidevconf's cool, multiply 5 and 10 gives 50. just for a bit of context, that's a JavaScript example of the exact same code. You can see how we have our comma, we use template strings, all that kind of stuff. So you can see how the Elm example is a bit less code and actually a bit simpler to understand. So one of the really beneficial features of Elm is everything's pure and immutable. For an example here in JavaScript to show mutable data, we have a person object and a birthday function. It takes person, increments the age by 1, and returns that person. So if we call birthday 5 times on this person object, it'll actually mutate the age and increment it by 1 every single time. So we can't rely on what the age of person will be at any one time. It makes your code unpredictable. It relies heavily on the order of execution, and it actually mutates state, which makes it extremely hard to unit test as well. So in the Elm example, Elm does not do this. You can't mutate data. Everything's pure and immutable. So if we change the age of a person by 1 and call birthday on the Bill object 5 times, it'll just return us Bill with an age of 2 every time, because it returns the new object. It doesn't actually mutate it. So we could go into our code and replace every single call to birthday Bill with that exact object notation. And that's a concept that's called referential transparency. So it makes your code a lot easier to reason about, and we can rely on what a value will be at any one time because it's pure. So another sort of real world example would be this get profile function, which basically has the GitHub URL for users, and it takes a username. It then creates an HTTP GET request, and this code here, believe it or not, it doesn't actually fire off the HTTP request. It returns what's called a command. And you'll see an example of that later, but a command is essentially what Elm uses to say, I'm going to do a side effect here, I'm going to go off and do a call, I'm going to do something with global state or whatever. And it gives us a nice divide as where our pure and impure code is in Elm apps. So the JavaScript example below, we're using fetch and we're using promises. You can't guarantee what that API call is going to return. So every single time, when we try to unit test that, we can't guarantee what's going to come back. We don't know every time. There's no reliability there. So you can see how the Elm example is a bit easier to reason about. So declarative versus imperative styles. It's one thing that's been going on for a long time, and I'm sure everyone here has at some point in their career seen code like this. It's very imperative, lots of try, catch statements, if, else. You're telling the computer how you want to do something, not what you want to do. And for me, I think it's a lot more difficult to understand compared to more declarative languages like Elm. So if we take an imperative example of a square numbers function in JavaScript, create a results array, use a for each, and push in the result, or push in each number squared and return the results. I know we could use a map here, but I wanted to show a sort of more imperative style with creating an array and pushing things into it. And then log it out, it gives us the squares of those numbers, which is right. We can rewrite this function in Elm with this code here. So we can create a square function at the top, takes n, returns us to the power of 2, and then we can call, we can map over a numbers array and call square on it, and then that gives us our square numbers. We can take that further again in Elm with an anonymous function. We can take away the square at the top, replace it with an anonymous function, and the syntax is a backslash, and then your function syntax. And basically that will do the same thing, maps over the numbers and squares them, gives us the same result. And we can take that even further in Elm, and with this code at the bottom, we have a map, and any of you that are familiar with Haskell or any language like that, we can wrap the operator there in parentheses, and it basically creates a function. We then pass 2 to it, so that says square numbers as a function, and then we don't need to pass the list explicitly. And we're able to do that through a concept called currying, which I'll go into in the next slide. So currying is essentially functional programming's answer to polymorphic structures, inheritance, that kind of stuff. No need for clunky design patterns. And I think it's a much more kind of lightweight way to build up context about behavior of the programs. So too long, no worries, basically we don't evaluate a function until we've passed all of the arguments. In Elm, every function is curried by default, same in Haskell. And you can do this in JavaScript, but it requires libraries, and you actually need to explicitly curry a function. So it's not enforced. So if we have an address function, takes a number, street, a city, we can call console.log out your address is number, street, city, and we can call that without all the arguments in JavaScript. So we can say for Sesame Street, and it'll say your address is for Sesame Street, undefined. So we could run into all sorts of problems, having not caught that edge case. In Elm, however, if we call that, we create the same function, and we only call it with 2 of its 3 arguments, it'll return us a new function that takes the last argument. So it won't actually evaluate until we pass all 3 of the arguments. And this way we can actually create context in functions by only passing a few of its arguments and sort of build up what way we want our programs to behave. So if we have a sort of more real world example, would be to go to a database and find a user. We create an HTTP GET request with it takes a DB URL and a user ID, and it creates what's, as I mentioned before, a command. We can then create a findUserMongo function which calls findUser with 1 of its arguments, and with the URL to MongoDB, for example. We can then call findUserMongo with 1 because the previous function returned for the findUser function, which waits on the last argument, the user ID. So you can see how we can start to build up context here, and we could use that findUserMongo function all around the app to signify we're going to go to MongoDB to get it. If it was some other data store, we could pass a different URL, create a different function, and use that. We have a more simple example, but it will be the add. So it takes X and Y. We can create a function called add12, call add with 1, and that returns us a new function. And then we can call add12 10, which will get us 11. And I mean, in my eyes, you don't get much more readable than that. So another really nice feature of Elm is piping, or the forward function applicator, which is a bit of a mouthful. So if we have a viewNames function, it takes names, and we basically work right to left. So we sort the names, and that'll be alphabetical order, and then we join them with a comma delimiter. We can refactor that viewNames function to the better viewNames function there. It takes the names, pipes them into the sort function, returns the result, and then pipes it into the string join function. So you can see how it gives us a nice linear flow and pipelines to transform data from start to finish. We can take another example of the square numbers under 10 there, and you see it's a bit mad where you have to kind of read right to left. We filter the numbers under 10, we map over them and square them, and we call it, and that gives us 16 and 4, which is right. We can rewrite that with the piping operator. Takes the numbers, pipes it into the filter to give us the ones under 10, and takes the numbers under 10 and pipes that into the map function, which then squares them and gives us our final result. And again, this is all pure and immutable. We don't mutate any state here. Another, probably the most powerful feature in Elm, in my opinion, is the strong test static typing and its compiler. So Elm's type system, in Elm we have what are called type signatures, and if you're familiar with Haskell, you've seen these before. We can create, I've been leaving them out of the previous slides because Elm actually infers types pretty well, but it's really recommended to write your type signatures so the compiler can pick them up and know exactly what it is you're trying to achieve. So we have hello world, string, is false, boolean, fairly standard stuff. The isCool function, it takes a string and returns a string, and that's signified with the arrow there. So the next one after multiply, it takes an int, it takes another int, and then it returns an int. The last type is always the return type. Well, list events is just list events. All lists in Elm need to have elements of the same type. And the has over n characters function there takes a string, the string you want to check, takes an integer, the number of characters you want to check if it's over, and then it returns us a boolean to say if it's over or not. So to show the sort of compiler messages, if we take that has over n characters function and we call it with nidevconf and 5, except 5 is a string and it's looking for an int, Elm compiler will actually blow up and say the second argument, the function has over n characters, is causing a mismatch. Function has over n characters is expecting the second argument to be an int, but it's a string. So not only does it tell you that something's wrong, it tells you which argument, which type it expects, and which type it should be. Another example, if we have the list of ints here, and we try and pass a dog into the end of it, it's not an int string obviously, this will blow up again and say the second and third entries in this list are different types of values. The second entry has this type, a number, but the third is a string. So it tells you which elements in the array are actually wrong, like down to the actual list index. So it's very easy to see for beginners and advanced programmers alike how to kind of solve these problems. So Taking the type thing further, Elm has what's called records and type aliases. And this is essentially how it deals with types for objects. We can create a Bill object with just a normal type notation. Say, Bill's an object, he has a name and a bio. And essentially, we can then create a hasBio function, which takes an object with a name and a bio and returns as a boolean just to say whether or not they have a bio or not. So that's all well and good, but we can rewrite that. Rather than having to use the object literal every time, we can create what's called a type alias. So the type alias user, name string, bio string, and then we can use exactly the same code, and instead of passing the full object literal, we can pass the type alias and say this expects a user, and it returns a boolean. So because we create a type alias, it actually gives us a constructor function. So rather than having to use the full object literal to create an object, we can just say user Bill, hey I'm Bill, like a function. So the first argument being the name, second one being the bio, and it'll give us the same effect. So just to show some more examples would be a programming language type alias and a slush puppy type alias. JavaScript programming language, and we can use the constructor function to say its name, creator 1985, JavaScript, Brandon I 1985, and we can create a large red slush puppy by saying large red and 250 passed into the slush puppy type. Obviously, for finite sets of types like large, like size or color or something like that, we don't really want to use strings. So in Elm, it actually solves this problem really nicely with what's called a union type. And we can rewrite the previous example with the slush puppy by creating a union type for the color. So it gives us red, blue, green, yellow, and because it's a constructor function, we can actually create a mix which expects two colors, and it'll be a type check it all for us. So you can see that's a slightly different syntax. It's not type alias, it's just type, and we separate each union type with a pipe. So we have a size one as well, small, medium, large, and then we can pass those into our type alias and say size is a union type size, color is union type color, and then price is just a float as normal. And we can then create instances of these objects by saying slush puppy, large, red, and you notice how we're using the union types instead of strings. And at the bottom there we have the party time example, which the large slush puppy mixes red and blue, and it's 2.50. So Elm will type check this all for us. There's no misspelling strings, there's no forgetting a union type. Elm will catch all of this at compile time for us. So a more kind of involved example would be how Elm deals with undefined or null case. And as I mentioned before, it uses a union type, and in this case it's the maybe type, and this is actually what it looks like in Elm's source code. So if you're familiar with Haskell or even functional programming in JavaScript, you've probably used the maybe type at some point. Maybe I have a value, maybe I don't. And it's a union type which either I just have the value or I've got nothing. We can create a remote data type, which is basically data from server, and it wraps the list of users we expect in a maybe. So it just says, we might have them, we might not. We then have this show number of users function, which takes the remote data, returns a string, which just tells us a wee message to tell us how many users we've got. And we can use what's called pattern matching. And again, it's pretty rife from functional programming languages, but it's essentially a really powerful version of a switch statement where we can match on the types of the union type. And one thing that we can see here that we can match on the just, and if the users come back, it'll say you have so many users, or if we get nothing, it'll say no user found. So the really nice thing about this is that if we leave out one of these branches and we don't catch the nothing case, or we don't catch the just case, Elm won't even compile. It'll say this case does not have branches for all possibilities. You need to account for the following values, and it'll say which branch you missed. So there's no not catching a certain edge case. It'll force you to catch every single one in the union type when you pattern match. And can we take that a bit further with rather than just or nothing, we can create a remote data type, not asked, loading, failure, success, and if we had a component in the front end that loaded some data, showed a spinner or something like that, we'd be able to do this very easily using this union type, and it would force us to catch everything and show, catch the loading state, catch the error state, catch the success. So Elm and the DOM, how does Elm deal with HTML? How does it deal with views? So these are actually benchmarks for the To Do MVC app, which I'm sure a lot of you are familiar with. And given these benchmarks, Elm's virtual DOM rendering performance was actually faster than React for that particular case. It's because we have immutable data and purity in Elm. So we don't have to do complex DOM diffs. Things are generally immutable and improve performance. And people actually use the likes of immutable JS and stuff in the front end to achieve these kind of benefits as well. So just to show a kind of a basic example with some HTML and a kind of full LMAP. LMAPs are split, sorry, it's a wee bit split at the bottom, sorry. So we have a main function which basically says, give me all the pieces to build up and start the LMAP. We create a model which is just a number of 0, that's generally an object, but in this case we just use a number. It takes a view function which we created and an update function. So in Elm, HTML looks like this. It's the div is actually a function. Li is a function, button is a function, and it takes 2 arguments. An array of attributes, your class, handlers, all that stuff, and then an array of its children. So we have a div container here, and we've got 2 buttons, and they have an on-click handler. And the on-click handlers of these are actually the union types that I mentioned. So when we click on one of the buttons, it'll fire off this union type as a message. It'll fire off an increment message, and then our update function will catch this and increment the model in a certain way. And when we increment the model, then it updates the view and we see it in the UI. Anyone who's familiar with Redux and React, Redux actually inherited from this. Its reducers are built off this model. So if you're used to Redux and React, then you'll find it very easy to pick this up. And again, you can't create a message and not catch it in the update. It won't even compile. So tooling and the Elm architecture. Elm has really good tooling built in. It's got a compiler and a bundler that compiles the JavaScript for you. It's got a REPL as well, so you can test your Elm code just in the command line. It's got a dev server called Elm Reactor, has hot reloading, all that kind of stuff built in. You just run it and it works. And the package manager, as I mentioned before, your enforced sort of semantic versioning, all that kind of nice stuff. And with the type system, it's able to really check whether code's solid or not. Whenever you're pulling in a new version or versioning your code yourself. So as I said earlier, I showed you an example. There's 3 sort of mainly cleanly separated sections. We've got our model, which is the state of our app, update, the way to update the state, and the view, which is just our HTML. So have we demo here? Have time for a wee demo? Is that alright? Yeah.
8 minutes.
Okay, no worries. Alright. So build a wee GIF generator thing here. It hits the GIF API on a sort of random endpoint and just generates a new GIF. But you give it a topic, and it'll create a GIF for that topic. So just to talk through how this kind of works. We have a main function, which has Elm provides what's called HTML program, which basically says this is our entry point to our app. It's an HTML program. It has an initialization function, which basically fires off some message to go and get data initially for the app. We have a view function, which we saw an example of earlier, our update, how the state gets updated, or reducers essentially, and subscriptions, which we don't need to worry about in this case, but subscriptions can be used to subscribe to DOM events, all that kind of stuff. Anyone familiar with the likes of RxJS or reactive programming, Elm provides all that kind of stuff for us as well. So we create our model. It takes a topic, which is the, as you see up there, dogs. And we have a GIF URL, which is our URL to go and fetch GIFs from the GIF API. Our initialization function takes a string, which is the initial topic, and it returns the model, and as I mentioned before, a command. So we can fire off a command here to do an HTTP call or something. So we pass in the topic, and it creates the model with that topic, in this case dogs. And I've just put in that waiting GIF there, and that's just like a default GIF kind of load at the very start. And then it fires off the get random GIF action with that message and the topic, which will go off and get it for us. So we have our list of messages here that we need to catch in order to update state throughout the app. We have the more please, which happens when you click the more please button, which will just hit the API again with the same topic and go off and get it, get the data for us and render a new GIF. We have the new GIF message, which has when the new one comes in, and we get a response back from Giphy. It'll either be okay or an error, and you can see there how we have to catch both cases. It won't even compile if we don't. So we have to change topic, which happens on change on the text box. So it'll change the topic and let us search for different types of GIFs. And each one of these is just a function which tells us how to update the state in a sort of pure, immutable way. And then we have the view. Nothing difficult there. We're just a div that has the input box at the top. It's got a button to click to get more. And then we've got the image at the bottom, which is just to actually display the GIF with the source from the state, from the GIF URL in the state. So that you can see there that the change topic and more please are on the on-click handlers here. Those are the union types from above, the action types, and it just says whenever I click this, fire off this message and update the state. Subscriptions, we don't have any, so it's just sub.none. And then we've got our actual API code here to go off and create our HTTP call. We have the getRandomGIF function. It takes a string for the topic and returns a command, which we can then use to go off to the server. And then we have the decode GIF URL in Elm. Decoding is important because we decode like JSON data we get back from server. It's basically a type-safe way of marshalling to and from JSON from server. And it's quite nice because it kind of it's able to catch if you can set required values and things like that on it. So you can make sure that you'll always have a certain value when you get it back from server. So just to kind of show how this works. I've tailored my phone, so I'm not sure how the internet will be, but some laser dead weird, like. Yeah. But basically, yeah, what's happening here? Click a button, update the state with our new GIF URL. That's a better one there. So obviously updates the state with our new GIF URL, creates a command which is then fired off to go and get the data. It comes back and it's caught in here for the new GIF, whether either okay or not. If it's okay, it basically updates it, the state with the completely new GIF URL, and the image has a new source that then renders it in the DOM. And that's it. Any questions?
Anybody got any questions then? Here.
What does the compiled JavaScript look like? Is it easy to debug, like when you do source maps, that sort of stuff?
So the actual compiled JavaScript, there's an Elm debugger. So actually, I think he was going example here. So you can go in here, and it's actually quite similar to the Redux dev tools if you've ever used those. This shows us our list of actions that were fired. And it's like a time travel debugger, so we can go back and see what the state of the app was at any one time. So it's quite easy to actually debug your Elm app before it's even compiled or anything. But as far as I know, there's no source maps or anything like that by default when Elm compiles to JavaScript. Yeah, go on.
But that's storing the state all in one place, similar to Redux does.
Sorry, say
You've
again?
got the state there, that's storing all the state in one place, like the same way Redux works.
Yeah. So that's it. It's just an object state tree, like exactly like Redux.
Does it provide any helpful functions like combining multiple objects if you want to separate your state into different sections? Do you have to define an ultimate object in the syntax, or can you compose it?
So see the way that see the way we define the model here. The only way I could, as far as I know, that you would do that is you would have to create a more nested object inside your model. So you would have essentially a different object to represent different parts of your app state, and then you'd have to sort of reach into that object and update it. So it would all be in that model object, as far as I know. But I don't think you can kind of split into separate reducers or separate parts.
Because they're just functions all the way, you can just have a different update function somewhere else
Yeah.
to specify one bit of it and just pull that and just
Yeah.
pipe the event and the model onto that
Yeah, that's it. So I mean, the whole thing is, yeah, absolutely. So even the views too, we don't have the concept of React components or anything. They're just functions. It's just input, output, and in this case, you know, returns HTML instead of string or int or whatever. And the whole thing is it is a very simple programming model, and it's sort of built around you know, building user interfaces. I wouldn't use Elm to build like websites or anything like that, but when you're, you know, when you're a front end to like a web application, absolutely.
If you wanted to integrate this with either existing code base or with existing NPM modules, how do you do that?
With JavaScript code, so Elm has what's called ports, and you can create your Elm app and render it. And you can, there's libraries to render as like a React component, but with a port, you can send data down to your Elm application through a port. So see the way you've got these messages here with the new. Oh yes, no problem. So you've got these messages here. We could actually send a new GIF message down to the Elm app from the JavaScript. It'll then update the state in the Elm app and return the state back to the JavaScript application. You can use it, so you can interrupt with JavaScript code with your Elm apps.
Thank you.
Thank you very much. Cheers.